This is example 3 for section 3.1. And here we are going to calculate a derivative again. So another example for that. Our function here is f of x equals x over x plus 1. So we're working with a rational function this time. We are going to find the derivative, find f prime of 1. And then we're going to find the equation of the tangent line to f of x at x equals 1. Okay, so a bit of a multi-step problem here, but we'll see how it ties together. So the very first thing we're told to do is to find f prime of 1. So we're going to use our definition of the derivative at a point. Okay, our point, x naught, is 1 there. So f prime of 1 is going to be the limit as h approaches 0, f of x naught plus h, so that would be 1 plus h, minus f of x naught, f of 1 there, all over h. Okay, so let's plug stuff in. Limit as h approaches 0, and we're going to plug in 1 plus h into our rational function, so up there, down there, plug in for those x's. Okay, going to have 1 plus h over 1 plus h plus 1 down in the denominator. Okay, and then minus f of 1. So 1 over 1 plus 1. All over h. Okay, let's simplify a bit. Limit h approaches 0. We got 1 plus h over 2 plus h minus 1 half all over h. And you know that all over h thing, it starts to get a little bit cumbersome here when you're working with a rational function. So here's a little notation, I don't know, notation hack for you guys. Notice how this is saying that we are dividing by h. So that is literally saying this, we're dividing by h. So instead, you could write that as multiplying by 1 over h, because divide by h over 1 is the same as multiply by the reciprocal 1 over h. So I usually find this a little easier when we're working with a lot of fractions on the numerator. So let's do that. I'm going to write this as limit h approaches 0 of 1 over h times that big numerator stuff. 1 plus h over 2 plus h minus 1 half. Okay, that looks a little nicer to me at least. It kind of keeps things in line better and you don't have to keep carrying around this huge fraction. Okay, so let's see, at this stage now, to keep simplifying, let's work on getting a common denominator for these two fractions there. So that would be limit h approaches 0, 1 over h, stuff that we just kind of have to carry around there, but hopefully it's a little easier now. We'll have 1 plus h times 2 over 2 plus h times 2 minus the second fraction would need to get multiplied by 2 plus h, 1 times 2 plus h over 2 plus h times 2. Okay, limit h approaches 0, 1 over h. Let's see what we got in there. All right, so our common denominator now is 2 times 2 plus h, or 2 plus h times 2. 2 plus h times 2. Okay, and up in the numerator we have 1 plus h times 2 minus just 2 plus h there, times 1 isn't going to do anything. All right, so that's where we're at right now. Let's rewrite that down here. Limit h approaches 0, 1 over h, and let's distribute. We're going to have 2 plus 2h, and then distribute here, minus 2 minus h, all over, I'm going to write those in the other order, 2 times 2 plus h, like so. Okay, notice a little bit of canceling up in the numerator there. So we're going to have limits as h approaches 0, 1 over h, keep carrying that around. And we're just going to have h up in the numerator there because we have 2h minus h. So there's h over 2 times 2 plus h. Okay, and this is another reason why I like doing this little swap here, making it all from a fraction over h and then just multiplying by 1 over h, because now we can see the cancellation really quickly. This h is going to cancel that h, so that's really nice. All right, so we've got our limit as h approaches 0 of just 1 now over 2 times 2 plus h. And that frees us up for direct substitution. So let's do that. Put in 0 for h, and we're going to end up with 1/4. Okay. So what we've just found, that is f prime of 1 equals 1/4 there. Let's write that. So f prime of 1 equals 1/4. Okay, so that was the first part to the problem there. Notice how we were told to first find f prime of 1. Then find the equation of the tangent line to f of x at x equals 1. Okay, so we're going to do the tangent line equation. And, you know, we'll get that into y equals mx plus b form. But the key thing to know here, the key thing to remember is that the derivative at a point gives you the slope of the tangent line at that point. Remember, that's from our definition directly, okay? Because the definition of the derivative here is the exact same thing that we were using to find the slope of a tangent line. So the derivative gives you the slope of the tangent line. All right. So the fact that we just found the derivative, f prime of 1, that's giving us the slope of the tangent line at 1. So that is pretty cool. So derivative at a point gives you the slope of the tangent line at that point. Okay. So here, f prime of 1 is going to equal the slope of the tangent line at x equals 1. Or really, I guess the point for that would be at the point where x equals 1, and then f of x, or f of 1, we actually found that already back here. F of 1, we did substitution, and it turned out to equal 1/2. So our point is 1, 1/2 for the x and then the y coordinates. Okay, so yeah, So our tangent slope is going to equal 1/4 because that is the value of the derivative at that point. So slope equals 1/4. Cool. All right, you don't have to calculate anything else there because we already got the slope. Now we can just use y equals mx plus b, put in the m that we found as part of the derivative. Well, it is the derivative. Okay, at that point. And then you can put in your point values. Y is 1/2. X is 1. So we would have 1/2 equals 1/4 plus b. Let's subtract off 1/4. Okay, 1/2 minus 1/4 is 1/4 equals b. And so our tangent line equation, we have found that really quickly now. It's y equals 1/4 x plus 1/4. And there we go.